everyone. Today we'll be looking at the February-March 2014 grade 12. It is going to be a lengthy video because we'll be covering question 3, question 4, and question 5, which will be organic chemistry. So let's get right into it. Question 3. The letters A to F in the table below represent 6 organic compounds. Before we even look at the questions, I want us to look at what is provided to us, and then we are going to draw the structural formulae. We are also going to identify the functional group, and then we are also going to try and name the organic compounds. Let's start with A. We have the structural formula is already given, so we don't need to rewrite that. What we can just do is to identify the functional group and then the name of the organic compound. Okay, so that belongs to the carboxylic acids. The functional group of carboxylic acid is identified by the carbonyl group together with the hydroxyl group at the terminal carbon. So what I have circled there in red, that represents the functional group of carboxylic acids. Now let us name. The first step is to identify the longest continuous carbon chain. So we are going to have that. That is the longest continuous carbon chain. And then we need to ensure that the functional group forms part of that chain. And then, yes, indeed it does. The functional group forms part of that chain. And then we are going to number our carbon atoms, ensuring that the functional group gets the least possible number. Okay, so we can number this 1, 2, 3, 4, or we can number from left to right. 1, 2, 3, 4. So when you look at the red color, you can see that the functional group is at carbon number 1. But when you number using the blue color, you can see that your functional group is at number 4. So we are not going to use the blue color because the functional group gets the least possible number when we are using the red color. Now, we have 4 carbons, so that is going to be but. The prefix is going to be but. Okay. And then we have, so that is a carboxylic acid. So it is going to be oic acid. That is going to be the suffix. So we have 4 carbons. So that is going to be butanoic acid. And then we said this belongs to the carboxylic acids. Now we are going to move to B. We have butan-2-ol. But means 4 carbon atoms. 1, 2, 3, 4. And then the 2 there tells you that the OH group is attached at carbon number 2. So that is the OH, which means that when you number, you need to number from left to right. Okay? And then that is just that. And then this is obviously an alcohol. Okay. And then C. Well, C belongs to the alkenes because of that double bond. So it is an alkene. And then now we have to name that. So it is obviously a ring. So our name is going to have some cycle somewhere because it is a ring. And then now let's follow the rules to naming. Of course, the longest continuous chain is just that part because those carbons are connected. And then now we need to number our carbon atoms, ensuring that the functional group gets the least possible number. Okay, so this is 1, 2, 3, 4, 5, 6. Or we can number from here in the clockwise direction 5, 1, 2, 3, 4, 5, 6. Okay, so I want you to take note of this side group. It is a side group because you can see that all the other carbons are bonded to hydrogens only, except for that carbon there. So it is a side group. Now, when you look at the numbering, you can see that side group, it is attached to carbon number 3 when you're looking at the blue color, but it is attached to carbon number 5 when you're looking at the red color. So we want our side groups to get the least possible number when we are numbering. So the correct numbering is going to be the blue color. Okay, so this means that we have 1, 2, 3, 4, 5, 6. Okay, so at carbon number 2, we have a methyl group. So this is going to be 2 methyl. And then we have 6 carbons. But don't forget, that is a ring. So this is going to be cyclo. And then for 6, that is going to be hex. And then you can see that the double bond is at number 1. We don't need to put the 1 there. We can just say it is 2-methyl cyclohexene. Okay. And then this belongs to alkenes. Okay. Moving on to D. Pentanal. Pent means 5. And the null there at the end, it tells you that the functional group is what? Your aldehydes. So pent means 5. 1, 2, 3, 4, 5. And then we are saying that the null tells you that it is what? An aldehyde. Excuse me. The only way to have an aldehyde is if you have a carbonyl group that is at the terminal that is attached to what? To a hydrogen. So this right here, it gives you the functional group of what? Of your aldehydes. Okay, so this is going to be my aldehyde. This is the structural formulae of pentanal, and then it belongs to aldehydes. Okay, and then we are going to number 6. We have 2 carbons, so it is 1, 2, and then we have 5 hydrogens, 1, 2, 3, 4, 5, and then 1 OH. So this is going to look like that. So it is an alcohol. Okay, and then we need to name this. So we are going to identify the longest carbon chain. So we only have 2 carbons, so that is going to be eth. And then so we don't need to number this because it can only be at carbon number 1. Even if you switch, you move this OH to the side, it will still be at number 1. So this is just going to be what? Ethanol. Ethanol. Okay. Number 7. Methyl propanoate. Okay, that is definitely an ester. So this is how we can write the structural formulae. So carboxylic, your esters, they are made up of carboxylic acids as well as alcohols, propanoate. Okay, so this part will come from the alcohol. Meth means 1 carbon, so it is 1 carbon. It's going to look like that. So this comes from the alcohol, right? And then we are taking an alcohol and reacting with what? A carboxylic acid. So prop means 3 carbons, so it's 1, 2, 3. And then we know that the structural formulae for the functional group of a carboxylic acid must be that, right? Okay, and then we're just gonna fill the hydrogens. Okay, and the way that this happens, when you react an alcohol with a carboxylic acid, you produce an ester. And another thing that you produce there is water. So this hydrogen there is going to bond with what? The hydroxyl group to give you water. And then what we do is that we take the alcohol. So this is the alcohol. And then we join it with the carboxylic acid. So I'm joining it from this side. And then we have 2 carbons. Okay, that is the structural formula of methyl propanoate. So when you name this, you just cut the 2 through that oxygen, and then the first part will give you the name of the alcohol, which is methanol, right? And then the second part will give you the name of the carboxylic acid, which is going to be propanoic acid. So when you name this as an ester, you just say methyl, and then that is going to be propanoate. That's it. Okay. 3.1. Write down the letter that represents a compound that is unsaturated. An unsaturated compound is one with a double bond or a triple bond. We only have one such compound here, which is C. Okay, 3.1.2 is a structural isomer of compound A. Structural isomers have the same molecular formula, but different structures. Okay, so let's look at A. For A, you have 4 carbons, and then you have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 hydrogens and 2 oxygens, right? Okay, and then let's see. Let's look at F. For F, this is F, right? How many hydrogens do you have? You have 4. 1, 2, 3, 4. How many hydrogens do you have? You have 1, 2, 3, 4, 5, 6, 7, 8. And then you have 2 oxygens. So for F, you also have C4H8O2. So you can see that A and F have the same what? Molecular formula, but their structures are different. So the structural isomer of compound A is going to be F. Okay, 3.1.3, an aldehyde, that is D. Okay, and then 3.1.4 belongs to the same homologous series as compound B. Well, a homologous series, it refers to a group of compounds that have the same general formulae in which the members differ by a CH2 group. So B and E will have what? The same structural, no, will have the same general formulae because they both belong to what? To alcohols. So the answer there should be E. Okay. 3.2. Write down the IUPAC name of compound C. Okay, for compound C, I think we've already written it down. So it is 2-methyl cyclohexene. If you want the explanation, rewind the video. 2-methyl cyclohexene. 3.2.2 structural formulae of compound B. We already have that, so it's 1, 2, 3, 4, and then in carbon number 2 I have an OH group. Okay, and then 3.2.3 name of the homologous series to which compound F belongs to. It belongs to esters. 3.3 compound A reacts with compound E in an acid catalyzed condensation reaction. We are taking A, okay, so this is A, 1, 2, 3, 4. And then we are reacting that with what? With E. So this is C2H5OH. This is obviously going to produce what? An ester, because this is a carboxylic acid and then it reacts with an alcohol. Okay. 3.3.1 write down the general name given to this reaction. When a carboxylic acid reacts with an alcohol to produce an ester, this reaction is known as esterification. 3.3.2 the structural formula of the organic product formed. Okay. Remember what we said. We said whenever an alcohol reacts with a carboxylic acid, what happens? That hydrogen there, let's just say that OH is going to bond with that hydrogen to form water, and then we're just going to join the alcohol and the carboxylic acid. The alcohol has what? It has 2 carbons, so it is 1, 2, okay, with an oxygen, and then we are just going to join the carboxylic acid from that carbon, and then we have 1, 2, 3. We have 3 carbons to the left, 2, 3. Okay. If they had said that they want the inorganic product formed, that will be the water. Okay. 3.3.3 now they are looking for the IUPAC name of compound A. That's butanoic acid. Yeah, butanoic acid. Okay, moving on to question 4. Petrol is a mixture of hydrocarbons, many of which have the molecular formula C8H18. Write down the name of the homologous series to which hydrocarbons with this molecular formula belong. 4.1. So you can see there that you have 2 more, it's 2 times plus 2. So it looks like this. Let me just write it down. Here you have C8, and then there you have 8 times 2 plus A2. So this is 16 plus 2, which gives you the 18. And this general formula, it belongs to what? To alkanes. the structures of two compounds with the molecular formulae C8H18. So both of them have C8H18 molecular formulae. Okay, 4.2. Why are compounds A and B structural isomers? Well, they both have the same molecular formula, but different structural arrangement of what? Of the atoms. So we are going to say both have the same molecular formula, but different structures. Okay. And then 4.3. Which one of the above compounds, A or B, has a higher boiling point? Refer to the molecular structure, intermolecular forces, and the energy needed to explain the answer. Okay. So this is what happens. Okay, let's take A for example. We know that both of these compounds have the molecular formulae C8H18. But when you look at A is more what? It is more branched. But B is what? Is linear. It means that B has a larger surface area than what? Than compound A. What tends to happen is that the intermolecular forces, the strength of the intermolecular forces, it increases with an increase in what? In the surface area. So it means that the intermolecular forces in B will be stronger than those that are in what? Are in A. And this is simply because of what? Because A is more branched, so it has a smaller surface area. And then B is more linear, so it has a larger surface area. Okay, so now let us explain. They say which one of the above compounds, A or B, has a higher boiling point. That, of course, is going to be compound B, because we are saying that the strength of the intermolecular forces of B is greater than that of A, because B has a larger what? Surface area. So this is going to be B. Now let us explain. First of all, we are going to refer to the molecular structure, right? B is more linear. This means that it has a larger surface area. That's the first part. And then the intermolecular forces, we will say the strength of intermolecular forces increases with an increase in surface area. And then this means that more energy is needed to separate the molecules of B. Done. Now we are moving to 4.4.1. Okay, to 4.4. Compounds A and B can be used to prepare smaller hydrocarbons at high temperatures. Okay. The only reason why we break compounds, especially alkanes that are that have a very like long chain, it is to make smaller, more useful compounds. Because the ones that have a very long chain, they are less useful. And this process, we call it cracking. Okay, anyway, let's continue to read. In the presence of a catalyst, one such reaction is represented by the incomplete equation below. Okay, so we have C8H18 and then it gives C5H12 plus compound C. So this compound right here, when we add the carbon atoms, it must have the same as the one as in the left. And this is because we are taking C8H18 and breaking it down to compounds with a shorter chain, which are more useful. Okay, so here I'm going to need what? 3 carbon atoms, so that when I say 5 plus 3, it is going to give me that 8. And then I have 12 hydrogens, which means I need 6 more, so that it takes me to what? To 18. So this is 6. Okay, 4.4.1. Name of the reaction represented above. We said that's cracking. And cracking is simply just when you take compounds with very long chains and then breaking them down to compounds that are shorter and are more useful. 4.4.2. Structural formula of compound C. So we have 3 carbons and then we have 6 hydrogens. This means that this is an what? Is an alkene. So 1, 2, 3, 4, 5, 6. We are done. 4.4.3. A balanced equation using molecular formulae for the complete combustion of. Okay, so that is an alkane. Okay, let's just do this. When you take an alkane, for complete combustion, it means that we are reacting that with oxygen. And then the product there should be carbon dioxide plus water. That's just the general equation that you need to know. Okay, so now we are taking C5H12, reacting it with oxygen. I know that the product should be carbon dioxide and water. Now let's balance. I have 5 carbons on the left, so I'm going to need a 5 there. And then I have 12 hydrogens on the left, so I'm going to need a 6. The first thing that you balance is the carbon and the hydrogens. You leave the oxygens and then you balance the oxygens last. Now I have 5 times 2, that is a 10, plus 6, that is a 16. So I need 8 here. Let's double check. 5 carbons on the left, 5 carbons on the right, and then I have 12 hydrogens. I have 12 hydrogens on the left. 8 times 2, that is a 16. 5 times 2, that is a 10, plus 6, that is a 16. So it is balanced. Question 5. The flow diagram below shows the steps that a learner follow to convert but1-ene to 2but2-ene. Okay, but means 4 carbons. By the way, we are still continuing with that strategy where we don't look at the questions, we just use the information that is given to us to try and simplify the diagram or the compounds that we are given. So we are still doing that. But means 4 carbons, so it's 1, 2, 3, 4. Okay, and then at carbon number 1, I am going to have what? A double bond, because it's but1-ene. So this is going to look like that. Okay, so this is carbon number 1, 2, 3, 4. 4, that's but. And then in carbon number 1, I have a double bond. So that's but1 in. And then it undergoes a reaction to form a major product compound X. The only way for me to have a major product, to have it written like that, is if I have a hydrohalogen there. So when I take a hydrogen and then any of the halogens, so it could be chlorine, it could be bromine, it could be iodine, the halogens group, and then we are going to apply Markovnikov's rule. So in simple terms, what Markovnikov says is that give the hydrogens to the carbon that already has more hydrogens. Okay, so this is 1, 2, 3, 4, right? And then so I am going to break this double bond, and then I'm going to have that. I already have 2 hydrogens there. I have 1. So now we have to put the hydrogen and the halogen in that to form what? A haloalkane. So Markovnikov says that the hydrogen will go to the carbon that already has more hydrogens. So when we look at these two, you can see that this carbon right here has 2 hydrogens and the other one has 1. So the hydrogen is going to go there, and then the halogen is going to attach itself there. Okay. And then compound X is going to undergo a reaction to form an alcohol. Okay. So see, it's 1, 2, 3, 4. So I have 1, 2, 3, 4. The first carbon has 3 hydrogens. The second carbon has a hydrogen and an oxygen and a hydroxyl group attached to it. So when you have brackets like that, it means that that is a branch. Okay. And then the third carbon, it has 2 hydrogens. And then the last one has 3 hydrogens. Okay. And then when you move from a haloalkane to an alcohol, this is hydrolysis. We call this reaction hydrolysis, and it is a substitution reaction. You can see that we are substituting the halogen for an OH to form an alcohol. So we are substituting. Okay. And then the conditions for this, you need a diluted strong base such as sodium hydroxide. So it must be diluted. And then you need mild heat. Mild heat. So what happens if you use a strong base? The haloalkane is going to undergo an elimination reaction. So instead of forming an alcohol, it is going to form an alkene. So it is very important for you to be able to differentiate between the two. When you use a strong diluted base and mild heat, you undergo hydrolysis, so it is a substitution reaction. But when you use a concentrated strong base plus intense heat, the haloalkane is going to undergo what? An elimination reaction. Okay. And then we are forming what? but2 in. And then, so this is going to be 1, 2, 3, 4. And then in carbon number 2, I'm going to have a double bond. Excuse me. Okay. So this is an elimination reaction, and it is in accordance with Zaitsev's rule. So what Zaitsev says is that when you undergo an elimination reaction, you remove the hydrogen from the carbon with what? With the least hydrogens. Okay, so what does this mean? Now, I want us to look at this compound right here. It can either form one of these two. So it's going to undergo an elimination reaction. So I have 1, 2, 3, 4, right? I can either form a double bond at that carbon, or I can form a double bond at that carbon. So this will become a minor product. And this is because Zaitsev says that when you remove the hydrogen, you need to remove from the carbon with what? With the least number of hydrogens. But what have we done here? We have removed the hydrogen from the carbon that has what? That has 3 hydrogens instead of the one that has 2. So I'm going to form a minor product. But on my right hand side, look what I'm doing. I am removing a hydrogen from the carbon that has the least number of what? Of hydrogens. So this becomes my major product. Okay. You don't need to be able to define Markovnikov's rule or Zaitsev's rule. You just need to know how to apply them. Okay. So, yeah, we are done. Let's look at the questions. 5.1. Write down the structural formula of the functional group of but1-ene that belongs to the alkenes, and the structural formula for alkenes looks like that. The double bond. 5.2.1. Compound X is formed when but1-ene reacts with hydrochloric acid. Remember what we said. We said this but1-ene is going to react with a hydrogen and a halogen, which is exactly what's happening there. Okay. So they say name the type of reaction that takes place. So you are reacting an alkene with a hydrohalogen. So this is a hydrohalogenation reaction. It's hydrogen and halogen, so it's hydrohalogenation. Or you can say it is an addition reaction, because you are adding what? The hydrogen and the halogen. So you can also say it is an addition reaction. Or you can say it is a hydrochlorination. That would be correct as well. 5.2.2. Write down the structural formulae of compound X. I think we already have it there. 1, 2, 3, 4. So this is 1, 2, 3, 4. And then the halogen is going to attach. It's going to attach to the third. So this is a chlorine. Okay. And then 5.3. Compound X is converted to alcohol Z. Name the type of reaction that takes place. We are moving from a haloalkane to an alcohol. So this is hydrolysis. Or you can say it is a substitution reaction. It is substitution because you are substituting that X for the OH. Let's just fix that. So this is a hydrogen. The OH is going to be there. Okay. then 5.3.2. So write down the name or formula of another reactant needed for this reaction. We already said it is the diluted strong base, NaOH, and it must be what? Diluted. Because remember, if it's concentrated, it is going to undergo what? An elimination reaction. So it will form what? An alkene. 5.4. Compound Z is converted to but2ene in the presence of a concentrated sulfuric acid. So we are taking an alcohol and then producing what? An alkene. Okay. 5.4.1. Is compound Z a primary, secondary, or tertiary alcohol? Okay, so just want to try and explain something now. And then okay, when you have a carbon and then it is attached to 3 hydrogens like that, this is a primary alcohol. And then when you have that carbon attached to the hydroxyl group and it is also attached to one other carbon, this is a secondary alcohol. And then when you have that carbon that is attached to the hydroxyl group being attached to 2 carbons, that is a tertiary alcohol. Okay. Now let's look at compound Z. Compound Z is right there. And then it is that the carbon that is attached to the hydroxyl group, it is attached to 2 other what? Other carbons. So it is what? A secondary alcohol. 5.4.2. Name the type of reaction that takes place. We are moving from an alcohol to an alkene. So it is an elimination reaction or dehydration. Let me show you why. Okay. So we are moving from that to produce this. Notice how we no longer have the hydrogen that was there, and then we also don't, it is the OH that was there, and then we also don't have the OH. So we have removed a hydrogen and we have also removed an OH. So when you combine these two, they give you water. Or you have eliminated what? The OH and then the hydrogen as well. So that is why it is an elimination or a dehydration. 5.4.3. What is the role of the sulfuric acid in this reaction? We are removing water, remember. So the sulfuric acid acts as a dehydrating agent. Or you can say that it acts as a catalyst. 5.5. Another learner discovers that but2ene can be prepared using the incomplete reaction. Okay. So it's compound X. 1, 2, 3, 4. What was compound X? And then in the third carbon we have an X there. So it's 1, 2. So this was a chlorine. Okay. Remember what we said. We said that when you when you react a haloalkane with a strong concentrated base, what happens? It will undergo what? An elimination reaction. So this must be a concentrated sodium hydroxide, and then you also need intense heat or strong heat. And then what is going to happen? You are going to form an alkene according to Zaitsev's rule. So this is what is going to happen. You are going to have 1, 2, 3, 4. We said that Zaitsev says that we should remove the hydrogen from the carbon that has less hydrogen. So we are going to have the double bond being there. You see, we can either have the double bond there, or we can have the double bond there. But the double bond can't be there according to Zaitsev, because this carbon has more hydrogens than that one. So the double bond, it must come there. Okay, so now we are going to have that, which is the but2-ene that we are given there. Okay, this chlorine is going to get attached to what? To the sodium. And then I'm going to have salt plus sodium chloride. What else am I eliminating? I'm removing a hydrogen there, remember? And then that hydrogen is going to be bonded to the OH. So it is going to form what? Water. Which is why I have that, which is the sodium hydroxide. I have but2-ene, I have the salt, and then I have the water. Okay, so this is 5.5.1. The type of reaction that takes place, it is elimination, or you can say it is dehydrohalogenation, because you are removing a halogen with a hydrogen. 5.5.2. The conditions needed for this reaction, we said a concentrated strong base, and then you also need strong heat. If you use a diluted base, remember the haloalkane is going to undergo hydrolysis, and then you are going to produce the corresponding alcohol. 3. Formula of the reactants and product represented by each of the following letters. So your A, it is a strong concentrated base, and then your B is going to be the salt, and then the salt, and then you C, that is going to be the water.